Okay guys, this video we're going to check out some non-linear examples, mostly because I need to make sure you still remember how to graph problems like this. Oops. So, top equation. We'll just do that one in red. Y equals 3. That means I'm going to go to y is 3. And since there's no x in the equation, am I going to touch x? No, that means I'm going to have just a straight horizontal line. But now, this equation with these straight bars, that was our absolute value. Absolute value we labeled AHK. And yes, on your homework you have a couple absolute value problems. We have to find the vertex. It's at the opposite of H, comma K. So I'm going to have a vertex at 4, 1. Line of symmetry. And just like with quadratics that we just finished a unit on, we're going to pick a point to the right of our vertex. So let's say 5. And we're going to plug that into our equation. Two times the absolute value of, what is 5 minus 4? 1 plus 1. Absolute value of 1 is 1. Times 2 plus 1, we get 3. So I have the coordinate 5, 3, and I reflect that over my line of symmetry and draw my V. Solution to the system is still the point or points where the graphs cross paths. So in this case, I have two coordinates here at 3, 3, and here at 5, 3. So this example had two solutions. Okay. So while I've got you here, just look at some different scenarios. Parabolas could have two solutions, because if I have a U and maybe my line goes like this, how many solutions do I have? 1, 2. Not always going to have 2, because look what happens here. How many times did these cross paths? They only crossed once. What if I have an absolute value and then a line running perfectly by its side? This one would have no solutions. You can also use the 0 with the line through it if you would like. Or what if I graph a linear equation and then I go to graph my second one and it lies right on top of it? How many solutions is that? That is infinite solutions. Or you could spell out the word infinite if you can't draw the infinity symbol, but okay. Those are all different options of the amount of solutions that we could have. We could have no solution. That means they never touch or cross. One solution, two solutions, or infinite. Okay. Let's do one more example of a quadratic. And I might even go ahead and make this an inequality as well. Okay, so top equation I'm going to do in red. Standard form, ABC, so I have to find my vertex. I know it's a coordinate XY, but X, I have to use a little baby formula. Negative B over 2A. We get 2 for the X value of our vertex. And then what do we do to get the Y value? We plug it in. And we get 5. So I go to my grid and I'm going to plot my vertex on my parabola. Okay, 2, 5, line of symmetry. I find an additional point by picking something, so maybe 3. Okay, this is what you just took a test over. That's why I'm kind of talking through this quickly. And you end up getting 4 here. So 3, 4, I reflect. Now I've got to decide what kind of line am I going to create. So I'm going back up to the inequality. It's less than or equal to, so that means I'm going to draw a solid line. And less means I'm going to graph below. Right. Now the other problem is linear. I know it is because it's just a plain x. So I have a y-intercept of 5 and a slope of down 1 over 1. This line is going to be dotted and it's greater than, so that means I'm going to shade above. And I hope you all see the area that satisfies both is this little, almost like an orange slice section. So when you choose or write down a solution, you can pick a coordinate inside that shaded area. So maybe like 3, 3, 3. Would that work as a solution? Yes, it would. Is that the only solution? No, because of the inequality. So this is a solution. Anything on the solid red line is. Anything on the dotted line is not. Okay, and so you have open-ended solutions on the inequalities. If you have questions, please feel free to email me. We did this lesson in 2 days in class. And so just take your time and please reach out to me if you need